The textile industry has become the second worst polluting industry in the world. With a mammoth amount of waste from manufacturers and retailers and almost no textile recycling, it's an issue that's having a negative impact on the planet. Literally. But Deakin Associate Research Fellow Lucas Rosson is aiming to change that in some innovative ways. From chemical recycling to turning food waste into textiles, his research is showing that sustainable materials are possible. This is the story of how a young mining and engineering student made the switch to study materials science, uncover new insights about how we colour certain materials, and experience some happy accidents that would lead to new possibilities in textile sustainability. Recorded on the lands of the Wurundjeri people, this is Stories of Wonder. Lucas Rosson, thank you for joining us today.
No worries, Dom. Pleasure to be here.
Tell me a bit about your story. How did you end up at Deakin?
I started my undergrad at Deakin, actually, in mining engineering.
Oh, wow.
Yeah. So I was like, let's go make lots of money in the mines and don't care about anything. And then I got a little bit into that and I was like, okay, I definitely don't want to do this. Still want to do engineering because it's sort of maths and physics and that's fun to me. I know it's weird, but but yeah, so I looked up all the courses and looked up Deakin's mechanical engineering course and I was like, that's great. And Deakin's close to the beach, so that's perfect. So yeah, I started my undergrad there and it just sort of spiraled into a PhD really. So yeah, it was, I started I think in 2014 at Deakin and I'm still there just in a different sense as a staff member now in 10 years later.
Well, there you go. That's something Federation Uni doesn't have is being close to the beach. So we'll take it. Sustainability is obviously one of the big challenges of our time. What drew you into trying to help find a solution for something in there and when did that all begin?
Yeah, I don't think I can pinpoint it to a single moment, but it was sort of a number of things and a bit of a cascade. Like, as I said, it started at Federation Uni in mining engineering and they were teaching us a subject on how you might mine the moon one day. And I was like, oh, it's a bit weird. Maybe we should look after like the planet we're on now before we start worrying about going out into space and mining that stuff. And that got me onto the sustainability thing or the sort of circular economy where it's like, why don't we reuse the things that we have? And then I sort of was a bit interested in it, but didn't think much of it. I was still sort of young and very naive. And then in my final year of my undergrad, you do like a research project. Uh-huh. And mine was on one of the students and his supervisor had created something called like the eco printer, where it was like a off-grid solar panel and battery system that enabled off-grid 3D printing and plastic recycling. Wow. And so I got in on that project. I was like, oh, this is awesome, and just did a small part of an analysis for my final year project. Their whole system, they took it to the Solomon Islands to somewhere that didn't have like grid electricity, went to a tip, collected plastic waste, and then used the solar panels and the battery to melt that plastic waste down and 3D print pipe connectors to fix broken water pipes there.
Wow.
And I was like, whoa, this can have a real impact.
Yeah.
And pretty much from then I was like, yeah, that's what I want to do. I want to research sort of sustainable solutions, particularly around like waste accumulation and sort of climate change.
Wow. Yeah, those are such cool examples.
Yeah.
And so amazing that you went from like a mining engineering kind of thing where they were talking about mining the moon all the way in the other direction. So that's incredible. Let's talk about the textile industry. So it's become the second worst polluting industry worldwide. What are the main things that are contributing to textile waste?
I love this question. So with the contributors to textile waste, you can look at it there's two or three main contributors. So there's obviously the waste after the textile is finished being a textile. So after the T-shirt you're wearing sort of you've worn it once and you don't like it anymore, or you've worn it 100 times and it's got holes in it, that's going to landfill, basically. Like there's almost no textile recycling. So waste accumulation is one part of it, but also it's the pollution from manufacturing textiles. Right. So any textile, if it's polyester, cotton, manufactured cellulose fibres like the ones I work with, they have to go from a tiny little fibre or like a something on the scale of like a human hair into a garment, and the ways we do that are way more complex than most people really imagine. And because of there's all these steps to the process, each one of those steps has sort of waste and pollution associated with it. And the main one of those is the colouring and dyeing of textiles. So that's like the main contributor to the environmental impact of textiles.
How is that so?
So when you're dyeing textiles, there's some textiles like some dyes or some materials like some dyes and other materials like other dyes. So it depends on what you're trying to dye. But for instance, cotton, you need, I think, and I'm not a sort of textile dye specialist, but so these are rough numbers, but you need about 1 kilo of salt to dye 1 kilo of cotton, just so it makes the dye stick to the cotton a little bit better. So that's all well and good if you can sort of extract some of these things back out of the wastewater. But lots of this manufacturing is happening in sort of Southeast Asian countries that might not have the regulation that we do here. And so even though they say they're not, a lot of the time it's sort of they can be flushing the wastewater out into the local waterways and sort of damaging the environment in that way. But going back to the sort of the contributing factors to pollution and textile waste, it's if people will focus on, people buy too many clothes. I don't know what it is now. People say it's like 57 items of clothing every Australian person buys per year or something now.
Oh, wow.
Like that might not be the exact number, but it's in that order of magnitude.
I'm acting shocked, but if I really think about it, yeah.
Yeah.
For me.
And that's like, wow, that's really bad. It's our fault that that's happening. That's not necessarily true. That's the main sort of contributor to it. So recently I heard one of the professors from IFM, Chris Hurren, he spoke at a Philippines textile conference over in the Philippines, and he said Australian manufacturers or retailers throw away 50% of the textiles they purchase to sell.
Oh, really?
So we'll like import this, sell half it, throw out the rest, because they're trying to pick what items are going to be like sort of fashionable or popular, and if they get it wrong, which lots of the time they will, that's what they're throwing out. So it's really a systematic problem, and you can take it back to the textile industry or any industry. It's about our entire system is geared towards continuous growth. So it's like, your economy or your GDP didn't grow by 2% last year. Well, you're in a recession. Yeah. So continuous growth means continuous waste. So it's about sort of decoupling our manufacturing processes from growth. That's sort of one of the solutions that might help. But it's I've tried and tell people not to feel too bad about buying clothes because it's like it's not you. It's
follow the money.
Yeah, exactly.
Follow the money.
We're just like a product of our environment.
So talk to us a little bit more about why some of those processes, particularly with colouring, have to be so different for things like cotton and cellulose, and what is chemical recycling? Because that's really sort of what you're trying to innovate in. Yeah,
awesome. So where do I start with this question? There's a lot of, we're getting into the chemistry side of things here.
Buckle up, everyone.
So the reason for the different dyeing processes is just because of the chemistry of the materials. So say polyester has an extremely different chemistry to cotton, or the chemical in cotton is cellulose.
Okay.
So cellulose, water loving, polyester, hydrophobic and water hating.
Right.
So already there, if you're trying to sort of, if you think about the dye as a water will easily attach to cotton or cellulose, but it won't easily attach to polyester. So then if you've got a polyester cotton blend and you want to dye it as a fabric, you've got to dye it in the polyester dye and then dye it in the cotton dye.
Oh, wow.
And it's just those processes, like they usually use so much, like the chemicals that are in them, the sort of massive chemicals they use per mass of fibre is just like astounding.
One way of doing it for one material is already bad enough, really,
Yeah,
like waste enough. But to basically have a blend where you've got to do the same thing twice for each of those garments, very wasteful.
Exactly. And there are like natural dyes that can be used to colour, and they're sort of there's some very toxic dyes out there that aren't really used much anymore. And then there's some sort of conventional dyes, or the mainly used one, like commonly used ones. Then there's also natural dyes, but they're the sort of dyes that you get a naturally dyed textile and you wash it with your clothes, and then all your other clothes are. Natural dyes are harder to fix onto the fibre, so they'll sort of wash off.
So that's like
easier.
The pink shirt that you throw in with your whites, and then
all
of a sudden you've got 400 pink shirts.
Yeah, and then the more washes, the more the dye comes off. So it's called colour fastness, or wash fastness. So it'll reduce the colour or change the colour properties of it the more you wash it. So natural dyes, while they're like a good alternative, they still haven't, like you can create chemicals that fix them to the fibre better, but those chemicals are usually highly toxic.
Yeah, right. So it's a like constant
creating another problem.
Balancing act of how toxic and chemical full is this going to be?
Yeah.
So what is chemical recycling then? Chemical
recycling, it's important to sort of probably start off with why we use chemical recycling. So for cotton or cellulose, unlike polyester, cellulose can't be melted. So it will decompose before it starts to melt, whereas polyester, you can heat it up and it turns into a liquid, and then you can shape it into different things like fibres. If you heat cotton up in the same way, it's just going to like char and sort of turn to ash or catch fire. So to turn the cellulose into a liquid that we can shape into fibres, we have to use chemicals. So they can do things that temperature can't, and sort of pick apart the chemical groups that we need to pick apart to make it into a liquid.
Yeah.
And chemical recycling is it stems from a process that already happens to make cellulose fibres. So you've got cotton, they come as little fibres, they grow as little fibres that are picked and then go through a process to turn them into a yarn. You can also use wood chips from trees and dissolve them down with chemicals into a liquid and shape them into fibres.
Really?
And those fibres actually make up about 6% of the fibres that are produced in the world.
Oh, wow.
So cigarette butt filters, they're cellulose acetate. So they're sort of made from wood pulp.
Right.
But they're processed in a way it sort of makes them no longer biodegradable, or it makes them no longer cellulose. They attach something else to it.
Okay.
But if you've ever heard of, say, like viscose or lyocell or tensile fibres, they're like a high water absorbency similar to cotton. They're the wood pulp fibres.
Oh, wow.
So
okay.
There are already chemical processes to take cellulose and turn it into fibres.
Yeah.
And chemical recycling of cellulose works on the same concept, but just using waste cotton instead of chopping down the trees to get the wood pulp to make the fibres.
Okay.
And I think, I don't want to say it because it's not the right percentage, but it's something along the lines, if we chemically recycled 20 or 30% of the cotton waste fabric, we could completely replace all the wood pulp needed to make those fibres in the current mass that they're produced in. Right. So it's sort of somewhat of a viable solution if we can commercialise it and get it right.
How far away are we from doing something like that and having a holistic sort of solution that is scalable to sort of on a commercial level to solve this problem?
Good question. So I have no idea how far away it is. One recent, I think it was last year or the year before, there's a company I think they were out of Europe, called Renewcell, and they were making, it's called pulp, when you cut down a tree and get treat the wood chips with chemicals to make it into a pulp that can be dissolved and turned into a fibre.
Right.
So they were making a pulp alternative from waste cotton. But I think they actually went bankrupt last year. So I was like, oh, that's a big sort of hiccup in the sort of sustainability pipeline. But their product, it was called Circulose, their sort of waste cotton pulp. Their company was sort of like taken over, and the Circulose product has been retained. So it's still sort of coming along there. But I think the latest stats is it's like under 0.5% of fibres are produced from fibre to fibre recycling. So nearly all the recycled fibres out there now are melted down plastic water bottles that have been turned into polyester fibres.
Yeah.
In terms of like actual fibre to fibre recycling, there's really not much of it.
Yeah. Still a long way to go.
That being said, there's a lot of research into it, and there's a lot of sort of potentially useful solutions out there. And even moving away from waste cotton, like the last 2 years I've worked with a biotechnology company called Nanolose out of Perth, and they grow bacterial cellulose. So it's chemically the same as the wood pulp stuff, but they grow it from bacteria that produce it by breaking down food waste. So they're going food and liquor waste. So they go, here's some beer, it's traditionally made from like coconut water, but you can use anything that has the right nutrients in it.
Right.
So you can use sort of like beer waste, food waste, old clothes, some studies have used.
Wow.
So that's another alternative to like the sort of the chopping down the trees or the farming the cotton. You can make bacteria do the job for you, or use waste cotton. But yeah, I think it's the waste cotton is there's a few different things we have to consider, because if you have a product that's waste, it might have all these regulations associated with it, depending on where it's coming from. So if you're trying to say, all right, I want to import a waste to use as my raw material, then the government or sort of legislation in the country that you're trying to import it into might be like, well, is this waste hazardous? Like, what do we have to do to treat it? And then companies are like, too much money.
Yeah.
I'll get some trees to do it for me.
Yeah, it is kind of follow the money, but it's also kind of follow the bureaucracy and how hard it is to even kind of spread this kind of practice.
Yeah, and it's probably just because it's sort of unprecedented or new that it's like there's sort of systems that we have in place just trying to catch up to what the research is doing.
How have you and your team, I'm assuming, the people that you've worked with, like uncovered some of this stuff? And, like were some of these accidental discoveries coming from experiments and stuff? Yeah.
So particularly like the coloured recycled fibre work, that has spanned like a number of different researchers, and I'm just like a small piece in the puzzle. So my supervisor, Nolene Byrne, she was sort of working on with our old director, Zhongai Wang, working on like just recycling denim or recycling cotton in general with these new chemicals that they wanted to use. They're like environmentally friendly alternative to what they use in those commercial processes. And they'd already sort of started looking at, can we just use the coloured cotton as is and put it through the process, but cotton as sort of waste pre-consumer product has these properties that make it really difficult to process into fibres. So if you dissolve that down, it'll make a really thick or viscous liquid, that's hard to push through tiny holes to make it into fibres.
Oh, okay.
So you have to have that liquid has to have the right properties. So be sort of just thick enough, but not too thick to push through holes to make fibres. And that's what we found when I started my PhD. We were working on trialling different chemicals to lower that sort of viscosity of the cellulose liquid to a level that was suitable to making fibres. And it just sort of happened that one of the chemicals worked really well and also kept retained the colour in the fibre to a high level. So it was sort of like, ooh, we should use this.
Yeah.
And then it just sort of kept going from there. And then that was just the fibre. Then there's a whole team that's worked to manufacture this. So just spin all the fibres. That's what you call it when you're turning the liquid into the fibres. It's spinning. So to spin all of those, our research engineer, who's now the research initiatives manager at IFM, he spent days and days and probably weeks in the lab spinning enough of these sort of cones of fibres to then take up to the Future Fibres facility at Warm Ponds and for them to knit into a fabric.
Yeah.
So there's an entire team behind it. I'm just the lucky one that gets to come on the podcast.
Yeah, to come on this fantastic podcast. You must have hit some roadblocks along the way, like things that didn't work or moments where it just seemed like a complete blocker. Can you talk about some of those and what kept you going?
Yeah. COVID. That was in the middle of my PhD. So that was one that was hard. It was some of the work that I was doing on they call it the wet spinning line to make these fibres. It was sort of like a ghost town in Warm Ponds, and you sort of by yourself wearing a mask walking around this empty facility, and it was a bit a bit surreal.
Bizarre.
Yeah, it was. So that was weird because you rely so heavily on the team environment. It's hard to stay motivated when you're sort of just doing it yourself. But I think in terms of roadblocks for this project, there weren't that many. It was sort of it all fell into place quite easily. It was recycling this and making coloured fibres like this. That's one part of the picture. But in terms of my PhD, we took it further and looked at the sort of different compositions of fibres you could make. So I worked on they're called bicomponent fibres. So in this, it's knitted together with yarns, and each of those yarns have 100 fibres or filaments in there.
Yeah, right. Wow.
So I was looking at, for each of those individual fibres, what happens if you put if you have one material in the core of it and one material on the outside. So the holes you're squeezing it through, it's got a little hole in the middle and a bigger hole on the outside, but the holes are still very, very tiny. Mm-hmm. So we went further and looked at if we could put a proportion of the coloured material on the outside of the fibre and not worry about colouring the material on the inside, what do we have to do to make it a similar sort of colour strength or have colour properties to this? And we found that you could use 50% of the mass of the fibre could be on the outside and coloured, and the other 50% on the inside didn't matter what it was, and it would achieve the same colour.
Wow.
So to do that was I had to look through do all these experiments and 3D print some parts to print the little prototype. I mean, to extrude the little prototype fibres. And there were some roadblocks there. That was sort of that's the real PhD work, where you get to the 2-year mark and you're like, what am I doing? Does any of this make sense?
Yeah.
But yeah, I think it just shows how important it is to have the right people around you when you're doing that stuff. It sort of seemed easy because every time there was a problem, there was someone I could be like, what do I do?
Yeah, totally.
Yeah.
Wow. In the weeds, in the fibres, literally. That's incredible. Look, you talked a little bit about it there. What were the facilities that you got to use and how important were they in uncovering some of this stuff and pushing this project ahead?
Yeah, super important. So the facilities at IFM Warm Ponds, they're sort of like our Textiles and Fibres research group is number one textile research group in Australia. So that is partly due to like the awesome facilities we have. And it's recently we sort of acquired some equipment that allows us to make garments like this or textiles like this. And it's called the Future Fibres facility, and it's part of like the Australian Research Council Future Fibres Hub. And that's been going, there was a previous hub that was 5 years of funding from the ARC, and now we've got another 5 years, and it's allowed us to sort of staff and run the Future Fibres facility. But then also down at, that's part of the Warm Ponds campus, but in the main part of IFM, even without that facility, there's a small scale wet spinning line that allows me to extrude the fibres, but at a sort of textile scale or textile quality. Because if your usual spinning studies, there'll be someone with a little pump and they pump the liquid through a blunt needle into a beaker and they're like, look, fibre. Whereas this, you can make fibres that have the scale, like the size, similar to those in textiles, and then you can do the characterization or the testing and compare it directly to textiles. So that the wet spinning line they've got down there, I practically lived on it throughout the 3 years of my PhD, and it's part of the Australian National Fabrication Facility, or the ANFF, and they have sort of nodes in universities throughout Australia, and you can use their equipment at those different universities.
Cool.
The equipment they've got down there, it's just it makes the research so much easier because you're never sitting there going, oh, how do I prove this, or how do I show that my fibre has this property? Because you know you're going to be able to just go like find the right machine for it.
Yeah.
So it was pretty lucky doing it there and having all that sort of in within reach.
Yeah. Talk to me a bit about the future of this research. You know, what kind of equipment are you excited about possibly seeing in the future that'll make it easier? Talk to me a bit about AI, whether that will play a role. Yeah,
definitely. In terms of my research, I am somewhat pivoting. So since I've done finished up with my PhD, I've worked on batteries for about 6 months, like sodium-ion batteries, and making them out of waste, such as waste cotton and other waste from the sort of the water industry. Yeah, you can use lots of different bio-based wastes as components in batteries. So I got a bit into the let's use this waste type instead of that, and that was fun. And then I've worked with like I said before, a biotechnology company to develop or to try and discover new chemicals or new processes to make textile fibres from their bacterial cellulose that's grown from food waste. And that was really cool working with them for 2 years. I got to work closely with like the CEO and the sort of second in charge, or I'm not sure what he had a long fancy title.
We'll insert it here.
Yeah. But that was great working with them. And now, I've sort of pivoted further and looking into artificial intelligence and machine learning to help guide us in what materials or chemicals we should use to make sort of the best and most sustainable fibres. So I think it's just the beginning of that journey, but I'm interested to see where it goes.
You spent a long time at Deakin. You're now an Associate Research Fellow here. What's kept you here all this time?
Good question. So I think it started off as more out of convenience. So being a lifestyle choice of I want to be close to the beach so I can go surfing. And it changed to being about having access to those facilities that we talked about before, and also just the opportunity to work with like various different institutes and various different experts. So, for example, when I sort of talked to my supervisor about wanting to use AI or machine learning in my research, he was like, yeah, sounds good. We should talk to these guys from Switzerland and from Finland as well.
Right.
And so like it's just having people that know or that have that network and being able to introduce you or encourage you to sort of expand your network and become like a sort of global researcher while still being able to have the lifestyle of living down around the coast and being at Deakin down there. But yeah.
Has it been a supportive environment? Have you developed a bit of a community?
Yeah, definitely. Yeah. You never feel like you're inconveniencing someone if you ask them a question. Like we've got a massive, well, I don't know if there's actually heaps of them, but it seems like there's heaps of them. The technical support staff down there, they're just like, it seems like they can just help with absolutely anything. And then I found like you usually have your supervisor, or if you're doing a PhD, you might have 2 supervisors. And you can obviously ask them questions, but every other sort of academic staff or technical staff member that I've asked, they've always had the time to sit down with you or have a coffee with you and be like, what do you need to know? Or here's some advice. And even though the advice usually comes in the form of questions, that you got to take that from the academics because they're trying to make you think and come to the answer
yourself. They can't
yourself.
just tell you the answer.
Exactly, yeah.
And what opportunities and experiences, you've touched on it a little bit, have you had doing your PhD? Like, has it really prepared, has it felt really sort of rubber meets the road and that it's really prepared you for, a future beyond once your PhD is done?
Yeah, definitely. Yeah. During my PhD, we were sort of encouraged to do these like training modules, self-paced, or sometimes they have like their sort of set session times, but usually they're self-paced and they sort of train you in all different aspects depending on what road you want to go down. So they'll have ones like a masterclass in academic writing, so you can learn how to write better papers.
Right. Yeah.
And then there's sort of also programs available that are not run by Deakin, but they're like freely accessible through Deakin. Like there's I think it's called the BASE program, and that sort of trains you to come at your research from a commercial point of view and gives you the skills you need to translate your research into real world outcomes, or at least translate it into a form that you can pitch to sort of potential industry partners or potential future employers. But yeah, I think the most valuable skills that I got out of it were the soft skills. So being able to communicate your research or communicate your work in general to a diverse range of people. Say like if I explain my research to someone who has spent their whole life researching the crystalline structure of cellulose, that explanation is going to differ a whole lot to explaining it to someone who might work as like a designer in the garment industry or something. So it's like having that range of sort of technical knowledge and the skills to communicate it. I think that's one of the most important things that I got out of the PhD, because they make you do a lot of presentations. I don't want to scare anyone off.
Did you ever think that with the work that you're doing, you'd end up having your story be told in an ad?
No, never. No, I came at my PhD. I read a really good paper at the start of it. One of the academics suggested it, and it was, I think the title of the paper was "It's a PhD, Not a Nobel Prize," and I was like, I've read it, and it's all about like this is what your goal should be. Like you're not trying to solve every single problem in the world. You're just trying to show that you can contribute something new and meaningful to the scientific body of knowledge. and demonstrate that you can sort of work autonomously. Yeah. And so I was like, all right, I just got to get something done, like do a little thing, and it's a sort of stepping stone in building up a project that might have some real world impact or some sort of notoriety. And then, it just sort of, I think it's the colour. I think everyone's like, whoa, colourful fibres, so we better use this. But yeah, it's been pretty exciting experience.
Yeah.
Yeah.
Would you like to watch the ad?
Yeah, definitely.
Yeah?
Yeah.
Hey, can you see it?
See what?
The wonderful possible. Imagine you see the world drowning in fast fashion. So you chemically dissolve old cotton clothes into something new.
Whoa.
Thought you'd like that.
What about a PhD at 80? What?
Still got it.
Pop-up law clinics anyone can access?
Nice.
Or lifting others up through education.
Yeah, I see it now.
Yeah, you do. Deakin University. See the wonderful possible.
It's pretty awesome.
You like it?
Yeah. I like how well it was described in the emails that I got. They were like, oh, here's like, it was just like a couple of lines, like, this is what we're thinking of doing. And it's like, that's sort of exactly how I pictured it being.
So you've obviously already done a lot of amazing things, identifying sustainability solutions for the textile industry. You're still at the beginning of your career as well. If we were doing another one of those ads in like 10 years' time on you, what do you reckon the story would be? What do you reckon would be in that ad?
10 years' time is a long time to imagine. I would hope that I will hopefully have a bit of a research team. So have some people working with me on some or some like-minded people that want to research the same thing working with me. And hopefully, I really want to pursue this AI machine learning aspect, because I am very conscious that how fast this technology is sort of developing. And I think it's really important for us as scientists particularly, but just everyone in general to keep up with it, because I think it has tremendous potential to really change the world, as long as we don't sort of accidentally see any of the sci-fi concepts come out of it.
Yeah.
A bit of iRobot or something, or The Matrix. But yeah, I would like to be sort of, in 10 years' time, I'd like to be telling you how the program or algorithm that we developed has helped sort of reduce textile waste by this percentage or that percentage, or at least just had some real world impact. That's my main goal, just to get these wonderful ideas that everyone has in research to translate through to being the sort of rubber on the road, real world solutions.
It's a good goal. Well, Lucas, thank you for joining us today.
No worries, Dom. Thanks for having me.